So here we go. Good afternoon, everyone, and welcome to this lecture. This is lecture number 3, and we are still dealing with resistance, resistivity, and I think we did not start with Ohm's law. We were still dealing with resistance and resistivity, and I think we had just started with Ohm's law. We had seen V is equal to IR. The graph between V and I is a straight line, and those resistances, no, those bodies, those materials, those substances which follow this straight line graph, they are known as ohmic resistors or ohmic conductors or ohmic substances. Do we remember this? Yes or no? But remember, Ohm's law is not a universal law. Do we remember this?
Yes, sir.
Ohm's law is not universal. Ohm's law is not universal. It means that there would be bodies, substances, materials which are not going to obey this Ohm's law. And since they are not going to obey this Ohm's law, they will be known as what? They would be known as what? They would be known as non-ohmic substance or non-ohmic resistors or conductors. They are not conductors, non-ohmic substances. So there are substances or devices which are not going to follow this Ohm's law, and those will be known as non-ohmic devices or substances. Do we understand this? What are the examples of this? Non-ohmic bodies or non-ohmic substances, gases, rectifiers, thermionic valves, all these transistors, they are non-ohmic or non-linear conductors because their VI graph is not linear. And we will see this non-linear graphs in the chapter on semiconductors when and whenever we get to that chapter. So in those in that chapter we will see that the graph is not a straight line graph, would be curved. Do we understand this? Yes or no? Now for those type of bodies, the resistance is going to change at different points. So we have two types of we can have two types of resistances for those wires or those substances. One will be known as the static resistance. Now when we talk about the static resistance for these wires or these substances, it would be resistance between 2 points. As you can see here, if I calculate the resistance between this point and this point, point A and point B, I will draw a straight line joining point A and point B, and I will find the slope of that graph. Inverse of that slope will give me the resistance Y inverse, because here I have drawn the graph between I and V. Do we understand? It's not a graph between V and I. It's a graph between I and V. Do we understand this?
Sir.
So those bodies will have two types of resistances. One will be known as static resistance and the other one will be known as the dynamic resistance. This dynamic resistance is going to come in your chapter on semiconductors. Dynamic resistances will come in semiconductors. Now when we talk about this dynamic resistance will be the resistance at any given point. Here when I draw a tangent at point B, the tangent at point B will be making an angle phi with the v-axis. The inverse of that, the reciprocal of tan phi will be known as the resistance. Do we understand this? What I'm saying here?
Yes, sir.
So these would be non-ohmic bodies. We will come across these non-ohmic bodies, but not here. We will be coming across these non-ohmic bodies in the chapter on semiconductors. That is the only place where we will come across this non-ohmic bodies. Everyone has noted this down? Yes or no? No, yes.
Noting, sir.
Um, Basically, what you need to note down is that there are bodies whose graph will not be linear, and these are the four non-linear graphs that we will come across. We will be studying the graph of diode and semiconductors the chapter on semiconductors. So these are the two graphs that you must remember. Just draw them right now. Why these graphs are like this or why they are like this, that's a topic of discussion in the chapter on semiconductors. Okay, so I'll give you 2 minutes to draw them. Let me know once you are done. Okay, since you have noted it down, then we can move ahead and move ahead onto the next heading. And the next heading that we are going to write is resistance. We already know it. Let us go through it quickly and see what types of questions we can face in this resistance. Resistance R, denoted by R, and the symbol is like this. Anyone knows this? Yes or no?
Sir.
What is the resistance of a conductor, or you can call it as a resistor? What do you mean by resistance of a resistor? This is the property of a body or a substance by what? Hmm. Property of a body or a conductor or a substance by virtue of which, what does it do? By virtue of which what? Nothing. No one knows what is a resistance. No one knows it.
Opposes motion of electron.
Opposes flow of charge, sir.
By virtue of which it opposes the flow of current. By virtue of which it opposes the flow of current. What type of quantity it is? It is a scalar quantity. What is the unit?
Ohm.
Unit
Ohms.
is ohm, denoted by the letter ohm. You can also write it as volt per ampere. 1 ohm is 1 volt per ampere. If there is a potential difference of 1 volt and the current flowing through the resistor is 1 ohm, we call the resistance as 1 ohm. 1 volt current, 1 volt voltage difference, and a current of 1 ampere. What is the dimension? Remember the dimension of resistance, ml square T minus cube a raised to the power of minus 2. Remember this. Remember this. Remember this dimension. Now, since we have talked about resistance, in the same breath, let us talk about conductance. What do you mean by conductance?
Reciprocal of resistance, sir.
Reciprocal of resistance. So conductance is 1 by R. So what will be the unit? Unit will be ohm inverse. Sometimes you can write it as ulta ohm, reverse ohm, mo, mo. Sometimes it is also known as Siemens. It's the inverse. So dimension is also inverse. What will be the dimension of this? It will be the inverse of it. Do we understand this? So it will be m minus 1, L minus 2, T cube, and A square. Now, whenever you see a graph between I and V, which was the graph that we saw just now, the graph between I and V, the graph between I and V, and I have again drawn that graph for you, the graph between I and V. The slope of this graph, the slope of this graph
1 by R, sir.
which is tan theta, that will be equal to C, and that will be equal to 1 by R. This is conductance. Resistance is the property by virtue of which opposes the flow of current. Conductance is the property by which it allows current to flow. So the reverse of it. I'll give you 2 minutes to note this down. Let me know once you are done. Well then, if you have noted it down, we can move ahead and see on what all factors the resistance of a wire or a conductor or a body depend on. Factors affecting resistance of any wire. Yes. What do you think would be the factors that are going to affect the
Geometry of
resistance of
body.
any? Yes?
Geometry of body, temperature, and material.
Yes. Geometry of the body, and as soon as you talk about the geometry of the body, the first thing that comes to your mind should be the length of the wire. Yes or no?
Yes, sir.
What do you think will be the effect if a conductor is long or a conductor is short? Which one will have more resistance, long conductor or short conductor?
Long conductor.
Long
Conductor, sir.
conductor will have more resistance, so it is directly proportional. Resistance is directly proportional to the length of the conductor. Do we understand this?
Yes, sir.
It is very simple to understand. There is no logic. I mean, there is no physics behind it. This is, if I have a 10-meter long wire and if I have 1-meter long wire, 10-meter long wire will have more resistance. This is just simple common sense. Yes or no? No, yes. Then we come to the next point. What would be the next point? Again on the geometry part. Again on the geometry part.
We have cross section.
Area of cross section. Now, what will be the dependence? Will it be directly proportional or will it be inversely proportional? It will
Inversely,
be
sir.
inversely proportional. The more the cross section area, the more is the space for current to flow, and therefore, my dear friends, your current, sorry, your resistance will be inversely proportional to the area of cross section. More area means more space, more current, more electrons, and therefore more current. More current, therefore less resistance. Do we understand this? Yes or no? No, yes.
Sir.
It's very easy to understand this. I guess all of you have understood this, how it depends on these two quantities.
Sir,
Have you noted it down? Yes, beta.
other class has left, sir. Karnaka.
Other class has left. Okay. Let us wait for 2 minutes then. Okay, then we'll move ahead. We have seen that the resistance is directly proportional to length and inversely proportional to area. On what all other factors the resistance will depend on? Definitely, resistance will depend on the type of the conductor. Yes or no? If you have a conductor which is made up of copper material, copper wire, it will have different resistance. If you have a conductor which is made up of silver or gold, gold is the best conductor actually. That is why gold is costly. So if you have a conductor which is made up of different material, you will have because number of free electrons would be different. Therefore, conductance will depend on the material of the wire. Yes or no? No, yes.
Sir.
So resistance depends on the material of the wire. Wire which has more free conductors will have less resistance, and the wire which has less number of
Sir.
conductors will have more resistance. Yes, beta.
Sir.
Yes.
Please, sir, previous page, sir. We are writing. We are disconnected. Sir.
Note it down. Let me know once we are done. So we have seen how resistance depends on length and area. Now it depends on the number of free electrons. N, you remember that NAEVD wala N? Yes or no? The number of free electrons are more, resistance will be less. If number of free electrons are less, resistance will be more. So basically it depends on the material of the conductor. A conductor which has more number of electrons per unit volume will have less resistance and so on. Yes or no? So putting all these things together, I can write, putting all these things together, what we can write? Putting all these things together, what we can write? We can write this revolutionary formula: resistance will be equal to rho L by A. Resistance will be equal to rho L by A. Now we have to understand what all means what. What does R stand for? Huh? What does R stand for?
Resistance.
What does L stand for?
Length.
What does A stand for?
Cross section area.
Then this A, then this rho depends on what? It depends on the material. Yes or no? It depends on the material. It also depends on the temperature. It also depends on the temperature of the conductor or the temperature of the material of the conductor. This rho is a constant of proportionality which depends on the material and the temperature of the conductor, and this rho is known as what? Allu Arjun? Amitabh Bachchan?
Resistivity.
No, Allu Arjun here. It is known as resistivity of the conductor, which depends on two factors, which is the temperature and the material of the conductor. Do we understand this?
Sir.
Therefore, since R depends on rho and rho depends on temperature, resistance also depends on temperature. So the fourth point is resistance depends on temperature. In fact, resistance is directly proportional to the temperature of the body. For a conductor, we are talking. Resistance of a conductor is directly proportional to the temperature. Resistance of a conductor is directly proportional to the temperature. Do we understand this?
Sir.
In fact, we can have a formula for variation of resistance with temperature. R at temperature T is equal to R naught into 1 plus alpha into T. This is the shortcut formula of finding out the resistance of a wire at any given temperature. Resistance of the wire at any given temperature. What is R naught here and what is RT here? Can anyone tell me? What is R naught here and what is RT here? Eh? What is R naught here and what is RT here? Huh?
R naught is original resistance. R naught
R
is
naught is the resistance at 0 degree Celsius and RT is the resistance at T degree Celsius. And we can assume it is actually not a straight line, but we can assume it to be a straight line. And I know that you don't remember it. But this concept of temperature changes resistance, we used it in a chapter way back. Obviously, you will not remember it because you
Thermal
forget
expansion, sir.
thermal expansion. Huh? We did it to make a temperature scale based on the resistance of the wire. Do we remember this? Way back, way back. How to measure the temperature? Physical properties of body changes with temperature. What were the physical properties? Length of a wire, volume of a liquid, pressure of a gas, volume of a liquid, temperature of platinum resistance wire. That is the reason. So this is your temperature scale based on the resistance of a platinum wire. Do we understand this? So this has gone above our head saying bye bye. Bye bye. I'm going bye bye. Huh? We understand this or this has gone above our head?
Understood, sir.
Understood, sir. I know your understanding. Now this formula that I have written is only valid for less than 300 degrees Celsius. This is the formula that you will be requiring, but for greater than 300 degrees Celsius, the formula looks a bit different. Please first listen to what I am saying, then you can use your Xerox machines afterwards because there is no point of Xeroxing it when you don't understand it. This is the formula that is valid for greater than 300 degrees Celsius. Apart from alpha, beta also comes. All these are constants, temperature, coefficient of resistances. So all these are constants. So don't worry about them. Now from this revolutionary revolutionary what revolutionary relation, you can find out the relation between alpha T naught and RT. Do we understand this? So remember this relation, temperature coefficient of resistance. Alpha, my alpha is RT minus R naught divided by R naught into T. Do we understand this? So this has gone above our head saying bye bye. Huh?
Understood, sir.
Pakka, sir?
Yes, sir.
All these questions are going to come in your exam, but then don't come and say, sir, we don't remember this, sir. And this has gone above our head, sir. Bye bye, sir. We are saying bye bye, sir. Anyone understands this? Yes or no? Huh? First, I will say, then you will speak. Then you will start your Xerox machines. Now, and question based on this has come in many JEE and many NEET. If R1 and R2 are resistances at temperature T1, remember degree Celsius, then you have this revolutionary formula. Do I need to make you understand this or you are good enough to understand how this has come? Yes or no? No, yes. Huh?
Sir.
Understand this or gone above our head saying bye bye?
Understood, sir.
Pakka no, sir?
Yes, sir.
Pakka is very kacha. Now I will give you 2 minutes to note this down. Note it down. Okay, then we have to move ahead in life and we shall move ahead in life. So this is the question that comes to you. Let's see what you can do with this one. This is the question. The temperature coefficient of resistance of a wire is 0.00125 per degree Celsius. At 300 Kelvin, the resistance is 1 ohm. What is the resistance of the wire? At what temperature? The resistance of the wire will be 2 ohms. And you have 1 minute, 2 minutes to show your talents? L, I will have to show my talent. And the answer is
B, sir.
option B, sir. So, how are you supposed to do this, sir? Resistance at 300 Kelvin is known. You have to find the resistance. At what temperature will it become 2 ohms? R1 by R2, 1 plus alpha into T1 divided by 1 plus alpha into T2. Now remember, this T1 and T2 must be temperature on the Celsius scale. Do you understand this? Yes or no?
Yes, sir.
So I just now put the values. Temperature 1, the resistance is 1 ohm. At second temperature, the resistance is 2 ohm. 1 plus first temperature is 300 Kelvin. So that is 27 into alpha. Alpha is 0.0. You don't have to write it here. You can just write it as alpha. Get your final answer in terms of alpha and then multiply it there. Divided by 1 plus T into alpha. I'm calling T2 as T. From there, you can find out the value of T. What is the value of T coming? I think the value of T is coming as 854 degrees Celsius. So you can convert this 854 degrees Celsius into Kelvin, and the answer that you are going to get is 1127 Kelvin. Everyone got this? Yes or no? No, yes.
Yes, sir.
Pakka? No doubts on this?
Pakka, sir.
I'm afraid of your pakka, sir. Your pakka gives me trouble. Anyways, with your pakka gacha, we move on to this question. Question number 2. The resistance of a wire. Same question I think I saw in one of your JEE last years, I think. The resistance of a wire at 20 degrees Celsius is 20 ohms. And at 500 degrees Celsius is 60 ohms. At what temperature it will be 25 ohms? I'll give you 2 minutes to get me this answer. So everyone got the answer for this one? Yes or no? So again, you can just apply this formula. R1 by R2 is 1 plus alpha into T1 divided by 1 plus alpha into T2. In first case, you can put R1 as 20, R2 as 60. That will be equal to 1 plus alpha into 20 degree. Or let me not write like this. Let me write it as 20 alpha divided by 1 plus 500 alpha. Do we understand this? Yes or no?
Yes, sir.
From here, you can find out the value of alpha. What is the value of alpha you are getting?
1 by 200.
1 by 200 or 220?
220, sir.
1 by 220. Now, what do you do in the next step? You know alpha. You can again write the same formula. 20. Now, the next resistance is 25 is equal to 1 plus alpha is already known. Alpha, again, I need to reverse. 1 by 20 alpha upon 1 plus 25 into 1 plus alpha into T. From there, you should get the value of T. What is the value of T that you are getting?
80, sir.
80. So just have to apply it 2 times. Everyone got this? Yes or no? No, yes. Everyone got this? Yes or no? No, yes.
Sir. Got it, sir.
Pakka, sir?
Pakka, sir.
Okay. Then comes the next question for you. And this is the question. Comes on your screen now. Question number 4. The VI graph for a conductor at temperatures T1 and T2 is shown. What is T2 minus T1 proportional to? T2 minus T1 proportional to, remember, the angle of T2 is given as theta from the V-axis, whereas the angle of T1 is given as theta from the x-axis. Do we understand this? Yes or no? I'll give you 2 minutes to solve this question. Let me know what is the answer. Well, the correct answer is definitely option C. How did you get it? Now remember, at 2 different temperatures, the graph is drawn, and this is a VI graph. This VI graph gives you the slope of this VI graph, gives you the resistance. Yes or no? Now, the resistance at temperature 1 R1 will be proportional to tan theta. Yes or no?
Sir.
And that is proportional to T1. Yes or no?
Sir.
Similarly, your resistance R2 will be proportional to tan of 90 minus theta, which is cot theta. Yes or no?
Sir.
And that will be proportional to T2. T2 is more, so R2 is more. So T2 minus T1 will be proportional to T2 minus T1 will be proportional to cot of theta minus tan of theta. Do we understand this?
Sir.
Now, once you understand this, you can write cot theta as cos theta by sin theta. This is one of the simplest trigonometric ratios to solve, and I will not go ahead from here. In the numerator, you will get cos square minus sin square. That will be cos 2 theta. In the denominator, you will get sin theta cos theta, which is sin 2 theta by 2. Cos by sin will be cot 2 theta, and that would be your answer. Do we understand this, or this has gone above our head saying bye bye? Bye bye.
Understood, sir.
Bye bye. Everyone has understood this, yes or no? Huh?
Sir.
Sir.
Pakka?
Pakka, sir.
Okay. So let's continue our journey. We were dealing with what all factors resistance depends on. We have seen that resistance depend on the material, the length, the area of cross section. Now, as soon as this area of cross section comes on, the resistance also depends on between which 2 points, your conductor is connected, and the resistance of the same body, if this is your conductor or this is your resistor, the resistance also depends on how this conductor is connected, and therefore you will have different resistances if it is connected in different ways. So different resistances of the same conductor. How we can have the same conductor, but the conductor may have different resistances. You can take them as examples, or these examples are not examples, but they are questions in themselves. For example, I have a conductor, and just to make this question interesting, I have taken a cuboidal cuboidal conductor, something like this. Cuboidal. Opposite faces are all rectangular in shape. Rho is the resistivity of this conductor. Sometimes I call it specific resistance also. This conductor has three different dimensions. This is A, front dimension. This is B, the height, and the depth is C. A, B, and C. I hope you understand it. Now the conductor is connected in this fashion. The top faces and the bottom faces are connected to a wire, connected to a circuit. Top, bottom. Top to bottom, it is connected to a battery. What will be the resistance of this conductor? What will be the resistance of this conductor if I connect it in this way? Any idea? No idea. Get idea. What will be the resistance of this conductor? I'll give you 2 minutes to think about it. So, how are you going to find the resistance? Can anyone tell me what is the formula of resistance? Does anyone remember the formula of resistance? Just now we have discussed this.
Rho L by A.
That's it. You just put the value of rho, L, and A, and you are done. What was so difficult here? When you look at the area, this is the area of the conductor that the body is having. When the conductor is connected like this is the area that we are talking about. You don't know how to find out this area? Don't know how to find out this area? It's a rectangle, it's a cuboid. What is the area of this? No one knows how to find out the area of a rectangle?
A
I'm
into
waiting.
C, sir.
Yes. What is the area of this rectangle?
A into C, sir.
Was it so difficult that you could not do it? A into C. Area of this rectangle is A into C. It is connected from the top face to the bottom face. So this will be the length of the conductor. What is the length of this conductor then?
B, sir.
So difficult that you could not understand this better. So difficult. You could not understand this. That is your problem. You don't try even. Anyways. So what will be the resistance of this conductor if I connect it in this way? What will be the
Rho B
resistance?
by AC.
That's it. Was it so difficult that you could not do it on your own? Rho B by AC was the answer for this one. It was as simple as this. You don't trust your abilities. Whenever I give you a question, I give you a question because I know that you can solve it. I know it because I have told you enough things. that you can solve it. If I know that you cannot solve it, I will not give you that question only. I trust you, but you don't trust yourself. Anyways, this is the second way in which I have connected this. And again, I'm asking you the same question. If I connect the same conductor in this way, what would be the resistance of the conductor now? I will give you 2 minutes to give me the answer. So, in this case, if you talk about the area, this would be the area of the conductor because the wire is connected across these two faces, and this would be the length of the conductor. So in this case, the resistance becomes rho A by B C. We just have to look at how the conductor is connected, across which face the conductor is connected. You have to write the area of that face, and you just have to see the distance between the two phases, and you have your answers. Do we understand this? Comes the next one, the third configuration. Now the conductor is connected like this, front face through the back face, and then it is connected to a battery or circuit or whatever. In this case, can you tell me
Rho
what
C by
will be the area of this? What will be the resistance? As you can see now, the area is this one. How much is this area? And the length would be this one. How much is the length? So what is the resistance in this case?
C by BA.
Rho C by A B. And this is how, depending on how the conductor is connected across the battery in the circuit, the resistance varies. Why does it vary? Just because there are different cross-sectional areas, and there are different lengths. Do we understand this, or this has gone above our head? Saying bye bye, sir. Going, sir. Bye
Understood,
bye.
sir.
Bye bye.
Understood, sir.
Your understanding is very dangerous. I always get scared. Anyways, if you understood this, then comes this question, my dear friends. To lay down all the fear that I have, this is the question, and here it comes, question number 6 or 7 or whichever question is this. Let's see if you can do justice to what we have learned. Remember the dimensions, remember the units, because the only thing you have to remember looking at the option is the unit, because if you do a mistake in the unit, all the options are different in terms of units only. The dimensions of a block are this. Specific resistance, whenever we use this word specific resistance, don't worry, we'll come to it. It is known as rho, resistivity. Specific resistance of the material of the wire is 3 into 10 to the power minus 7 ohm meter. We will see resistivity, don't worry. What is the resistance between its opposite faces? Your time starts now. I hope all of you have done this. What is the answer, my dear friends?
Yes, sir.
D for Delhi.
C.
B.
C.
C is absolutely wrong, sir.
option D, sir.
Option D is absolutely wrong, sir. So you cannot apply the formula with the correct units. It's quite a shameful act. Rho L by A. You just have to apply it in the correct form. If you cannot apply it, I don't know what should I say. I will not say anything, so I'll just put the values and get the answer and stay happy. Rho is 3 into 10 raised to the power of minus 7 ohm meter. Everything has to be in the proper unit. What is the distance between the two faces? Yes, L. How much is L? No one knows it. 1 centimeter. That has to be converted into meters. So multiplied by 10 raised to the power minus 2 divided by the area of cross section. Area of cross section is 1 multiplied by 100. 100 centimeters square. It has to be converted into meter square, my dear friends. If you cannot divide this, I can't help you. The answer is B, and I will end my solution here. There is no point of going any further. I hope we understand this. Please note this down, and please remember, please understand that if you cannot multiply and divide, cannot convert centimeter square into meter square, well, you need to work hard on that. That's all I can add here. There's nothing more that could be added here. Everybody noted this down? Okay. Then we will come to the next heading, variation of resistance of various material with temperature. Variation in resistance with temperature. Now we have seen what happens with metals. Their resistance increases with increase in temperature, but it is not a universal truth. And I have seen a lot of questions based on this concept, and therefore we'll have to note down what type of materials has what type of relation with temperature and their resistances. So the first one is metals. What will happen with metals when you increase the temperature? The temperature coefficient of resistance alpha is positive. That means when the temperature increases, resistance also increases, conductance decreases. Do we understand this? Again, the next is solid non-metals. For this solid non-metals, this alpha is 0. So their resistance is independent of temperature. Remember, these are certain points which you need to remember. They are information based questions, and these days these information based questions are in fashion. The third one, which will be coming in the last chapter whenever we get to that point, are semiconductors. And semiconductors have this very peculiar property that at low temperatures they are basically insulators, but as you increase the temperature, their resistance decreases and their conductance increases. So more the temperature, the more conductive they become. So semiconductors alpha is less than 0, and therefore their resistance decreases with temperature. The next one is electrolyte, that is from your chemistry. As you increase the temperature, your resistance decreases. So remember these points. Then you have ionized gases. Again, their alpha is less than 0. You can group the bodies whose alpha is less than 0 and alpha greater than 0 so that it becomes easier for you to remember these. Then we have your alloys. Again, this might be more important. Alloys are normally not asked in physics, but this may be important for you in chemistry. For alloys, the alpha is almost 0. It has a very small positive value, but we can take it as 0. So their resistances almost remain constant for alloys. Then there are other type of bodies which are known as superconductors. What are these superconductors? As you can see, as we have seen that the resistance of a conductor is directly proportional to temperature. Now, if you increase the temperature, the resistance of the conductor increases. But similarly, if you decrease the temperature, the resistance of the conductor also decreases. There comes a temperature where the resistance of a conductor at a low temperature, the resistance of a conductor may become 0. And in that case, those conductors are known as superconductors, and that temperature is known as critical temperature. So I hope that you will remember these terms: critical temperature and superconductors. Critical temperature is the temperature where a conductor becomes a superconductor, its resistance becomes 0, and they acquire superconductivity, and that temperature is known as critical temperature. Do we understand this, or this has gone above our head? Saying bye bye. Bye bye, sir. Bye bye, sir. Thank you, sir. Good day, sir. Take care, sir. Do you understand this?
Yes, sir.
I'll give you 2 minutes to note this down. Then let's move ahead. And since we are seeing this term specific resistance or resistivity coming so many times, let us now move on and see what do you mean by this specific resistance or resistivity, and then we will move ahead with the remaining problem: resistivity or specific resistance. So write the heading: resistivity or specific resistance, denoted by the legendary letter O, rho. Now, what is this resistivity or specific resistance? Now we know the formula that resistance of a wire is rho L by A. Yes or no? If the length of the wire L is 1 meter and area of the wire is 1 meter square, your resistivity becomes numerically equal. Remember, when I say numerically equal, they are not equal. They are numerically equal. Your resistivity becomes numerically equal to R. So resistivity is equivalent to the resistance of a body, a substance, a material whose length is 1 meter and whose area is 1 meter square. Do we understand this? It is a scalar quantity. And now you can easily see its unit. Its unit is ohm meter. Do we understand this ohm meter? Its dimension. Its dimension. You multiply resistance by meter and you get this dimension: m L cube T minus 3 A minus 2. That is the dimension. What does this resistivity depend on? Resistivity rho.
Nature of the medium.
Yes, beta? Resistivity rho is an intrinsic property of the body. It is an intrinsic, internal property of the body. Do we understand this? Everyone can hear me, everyone can see me, yes or no?
Yes, sir.
Since it is an intrinsic property, it does not depend on what?
Size and shape, sir.
Yes, it will not depend on the size and shape. It will not depend on the size and shape of the body. Then what it depends on?
Nature of the
It depends on the nature of the body. Rho depends on the nature of the body. But there is one more thing on which rho depends on. Rho depends on the temperature of the body. Rho depends on the temperature of body. And what is the formula for the variation of rho? Rho at temperature T is rho at temperature 0 degrees Celsius plus 1 plus alpha into T. Remember, this is the formula for variation of rho. Because rho varies, therefore your resistance varies. It's not the other way around. Do we understand this?
Yes, sir.
I'll give you 2 minutes. 2 minutes to note this down. Since you have completed this, we must move ahead. Now remember this formula that I have written for rho. This formula is only valid for metals. Only for metals this thing happens. Because we have just now seen that resistance of all bodies do not increase with increase in temperature. Do we understand this?
Yes, sir.
This formula that I have written is basically only meant for metals, and this is the graph, and this is the exact same graph that you have for the variation of resistance. This is the exact same graph that we have for variation of rho of a metal. Do we understand this graph?
Yes, sir.
But for semiconductors, the graph looks different. Why does it look different? Why will it look different? Because rho does not increase. In fact, it decreases. Are you able to understand what I'm saying here? And since we have talked about semiconductors, you must understand that semiconductors are nothing but conductors at low temperature. When the temperature increases, their resistivity also increases. Everyone understands this, yes or no?
Yes, sir.
I'll give you 2 minutes to note this down. One more thing here, you can just note down this order of resistivity of different bodies together with this thing that we are noting down. So order of resistivity of different bodies. Resistivity of an insulator is the highest, followed by alloy, followed by semiconductors, and the last is conductors. So now you can note down the entire thing. Let me know once you are done. Okay, well done. We have noted down this. Then there is one more thing that remains. Since we have done resistivity, we have to do the inverse of that, and that is known as
Conductivity.
conductivity. Conductivity, sigma. And no prizes for guessing this. Sigma is nothing but the reciprocal of rho. Reciprocal of rho. So its unit become ohm inverse, meter inverse, or sometime it is written as mole per meter. Mole per meter. The dimension, what are the dimensions of rho? The ulta is the dimension of conductivity. Can you tell me what is the dimension of conductivity then? No one remember the dimension of rho. You have to remember them, beta. M minus 1,
-3
L minus 3, P cube A square. Cannot forget this, beta. Not, I cannot appreciate it. Now you can write the formula of resistance. Resistance was rho L by A. You can write it as L by sigma A also. Doesn't matter. Both are similar things. Do we understand this, or this has gone above our head saying bye bye?
Yes, sir.
Okay. Now, apart from this, just don't write it. I will just give you one more small thing I've seen in one of the previous papers. So note down. I missed one point here. Mobility of electrons. So just note this down as well. Mobility of electrons. This is denoted by mu. And what is this mobility of these electrons? This is drift velocity. So,
drift velocity by electric field, sir.
yes, drift velocity per unit electric field. So your mobility mu becomes Vd by E. Remember this because I've seen it in some of the papers. So you should not miss this. Now I will give you 2 minutes to note this down, and then we can wind up this entire topic with some really nice questions. Your time starts now, 2 minutes. Then let us move ahead and start with questions to wind this up. This is the first question coming for you. Do it fast and give me the answer fast. And call this question number 1 to start off again. The specific resistance of something is given. You have to find out the resistance. Remember, the only thing that we are looking at is probably that you understand what we have done. Give you 2 minutes. Option A is correct, but you have taken a lot of time to do this. You just had to apply R is equal to rho L by A with the proper units. R is 50 into 10 raised to the power minus 8. Length of the cube is 50 centimeters, so 50 into 10 raised to the power minus 2 divided by area of the cube of any side of the cube will be 50 into 10 raised to the power minus 2 square. You just had to solve this, get the answer, and stay happy. Do we understand this? Yes or no?
Yes, sir.
Everyone got this answer?
Yes, sir.
Comes the next one. And this is the next one. All these questions are on similar type which are coming in the exam these days. A rod of a certain metal is 1 meter long and 0.6 in diameter. Its resistance is given. A disc of the same metal is 1 thick and 2 centimeters in diameter. What is the resistance between its circular faces? I'll give you 2 minutes to give me the answer. Option B is correct. So how are we supposed to do this? Very simple. Again, the distance is rho L by A. The blue is a rod 1 meter long, 0.6 in diameter, and the resistance is given. So I write it. Resistance of the rod in blue R1 will be equal to rho into length is 1 divided by area is pi into 0.3 square. Then for the disc, same metal, 1 mm thick, 2 centimeter in diameter. So let me call the resistance as R2 rho multiplied by 1 mm thick. So that is the length. 1 into 10 raised to the power minus 3 divided by pi. 2 centimeter in diameter. So 1 centimeter is the radius. 1 centimeter is 1 into 10 raised to the power of minus 2 square. Now I can find out the ratio. R1 is already known. R1 is given as 3 into 10 raised to the power minus 3. From here, I should be able to get the value of R2. Yes or no?
Yes,
Anyone
sir.
got this?
Yes, sir.
So R2 will be coming as B, which is 2.7 into 10 raised to the power of minus 7.
7.
Chalo. Anyone understands this or is going above our heads?
Understood, sir.
Next one. This one. An aluminum rod of length. Again, similar question, similar pattern. These are the questions that are coming these days. Can I have the answer for this one? So the answer is option C. And how are we supposed to get this? It is very simple. Again, the same formula comes. R is equal to rho L by A. The first case, blue case, aluminum rod length is this, and it is the area is given as 3.4 into 3.4 mm square. The resistance, let me call this as R. R is equal to rho into length is 3.14 meters. So 3.14 divided by 3.14 into 3.14 into 10 raised to the power of minus 6. Do we understand this? Minus 6? Because it is in mm square. They are only checking your units. What should be the radius of 1 meter long, another rod of same material to have the equal resistance? So the resistance is equal R rho into 1 meter is the length divided by pi into R square. From here, you should get the value of R. And I think the value of R that you are getting is 10 raised to the power minus 3 meters. And therefore, the answer is 1 mm. Everyone understands this? Yes or no? No, yes.
Sir.
Everyone got the answer? I am not able to see all of you. I don't know why. But anyways, I hope everything is fine. This is the next question. Now, I don't want you to get into the calculating part of this question. That is not the intention. The intention is to understand the concept of this question. And even if you're not able to get the numerical part, the answer part, what I want you to understand is the concept of this question. So here comes the next question. If you can, I'll give you 2 minutes. If you can get the answer, is good. Otherwise, I will tell you how it is done, because if this question comes, you may not get it as a numerical, you may get it as a question which has answer in terms of pi, r1, r2, and so on. That is a better way of asking this question. But here it is given in the form of numerical values, but we will try to solve it otherwise also. So I'll give you 2 minutes to give me this answer. Well, how are we supposed to do this? Let's not complicate things a lot. It just requires some calculations. I don't want you to get caught into that calculation stuff. So I'm just sharing this diagram. and I will try to solve it from this diagram, and I hope you are able to understand it from this diagram. So this is the cylinder that is given to you. The inner radius is R1 and the outer radius is R2, and you can call the length of this cylinder as L, which is also given. This is a hollow tube, the length is given. Now this question is given, the length is given as 5 meters, so not a problem. Length is given as 5 meter. Outer diameter is given as 10 centimeters, so you can find out the outer radius, which is R2. The thickness of the wall is given as 5 meters, so from there you can calculate the value of R1. Yes or no? Do we understand this? The only thing you have to do is just put the formula. Resistance is rho L by A. Rho is given to you. In area, you have to just write pi of R2 square minus R1 square. And you can easily calculate the value of R2 and R1. So this is the answer for this question. Do we understand this? Do we understand this, or this has gone above our head saying bye-bye?
Understood, sir.
Okay. I am not going to insist on you calculate this, because calculations may not come. And if the calculations come, they would be pretty simple. So as everyone understood the concept, this was just to make you understand that if a question comes on this, and they can give you in JEE Mains and JEE Advanced, I told you that gave you a truncated cone. So this time they might give you the hollow cylinder. So remember, this is the resistance of this wire. I hope you have noted this down. That takes me to the next question. Shall we move on to the next question? Yes or no? No, yes. Nah? No one is saying anything.
Wait,
Can we
sir.
move on to the next question? Huh?
Yes, sir.
This is the next one, question number 8 or 9. I have lost count. The more the number of questions that we do, the better we are going to be. Equal potentials are applied on an iron and copper wire of same length. In order to have the same current flow in the wire, what is the ratio of the radii? Specific resistance of iron is given and specific resistance of copper is also given. You have 2 minutes to give me the answer for this one. So let me go ahead and solve it. How are you supposed to do it? It's the same thing that we have done. Resistance is rho L by A. But wait, how did resistance come? Well, equal potentials are applied and same current flow. Resistance is V by I. Potential is same, current is same, therefore the resistance has to be same, and resistance is rho L by A. The wire is also same length. Resistance is same. So now everything becomes very clear. We have the simple formula, rho by A will be constant for both the wires. Rho by A will be constant for both the wires. That means rho 1 by rho 2 will be equal to pi R1 square by pi R2 square. Do we understand this? Yes or no? No, yes.
Sir.
Yes, beta. So R1 by R2 will be equal to root over rho 1 by rho 2. And I think you are getting 100 by 7 ka 100 by 17 ka root. And it is approximately coming as 2.4. So that is the answer. Do we understand this? Or this has gone above our head saying bye bye? Bye bye, bye bye. I'm going bye bye.
Understood, sir.
Understood, sir.
What was the problem here? I don't understand the problem. It was a simple question. Where did you do a mistake? Anyways, this is the next question coming up. I have forgotten the number, so I'll start with question number 10. Question number 10. Masses of three wires are in the ratio. Masses. Up till now, we never had a question with masses. Anyway, masses of three wires are in the ratio 1:3:5. And their lengths in the ratio 5:3:1. What is the ratio of their electrical resistances? And you have 2 minutes to give me the answer for this one. So let me do it for you. The only formula we know is resistance is rho L by A. Now, if I have a conductor like this, the area of cross section is A and the length of the conductor is L. I can say that the volume of conductor is A into L. So now I can write this formula as rho. I can put A as V by L. Rho L square by V. This is another way of writing the same formula, just in a different way in terms of L and V. Do we understand this, or this has gone above our head saying bye-bye? Do we understand this? Yes or no?
Sir.
Then let me call density as D. Density is mass per unit volume. So from here I can write volume. Remember that original V was volume, and this is volume in terms of A and L. Now I'm writing volume in terms of mass by density is volume. So if I put here mass by density, resistance becomes rho L square by M multiplied by D, where D stands for density. Do we understand this?
Yes, sir.
That's it. Once I understand this, I can find out the ratio of R1, R2 and R3. R1 is to R2 is to R3 will be equal to L1 square by M1 is to L2 square by M2 is to L3 square L3 square by M3. Do we understand this? Yes or no? No or yes?
Yes, sir.
So this will be 25 is to L square is 9 by 3 is to 1 by 5. If you put it in the correct way, you will get the answer as option D. You can also remember these two formulae and keep them safe somewhere. Well, that brings us to an end of this class. In this class, we have taken long steps and we have almost completed resistance, resistivity. There are some points left, some questions left, which we will carry on in the next class. So I'll see you on the other side in the next class, and we'll try to wind this up and move on to the electrical measurement part. I hope everyone has understood what we have done in today's class. Yes or no?
Yes, sir.
Please do practice these questions at home. Trust me, one of these questions is going to appear in your exam. I have full faith. So try these questions at home, and I'll see you in the next class. Take care. God bless you. Bye bye.
Thank you, sir.
Bye, beta.